Hi, students. How are you? I hope you all are fine, right? And this is our lesson number 7, and it's related to materials and Hooke's law and everything. So let's talk about that, right? Now, what is actually a Hooke's law? That's what the point is. So for that, let's talk about Hooke's law. First of all, important thing is when you're talking about a Hooke's law, important. Actually, Hooke's law is explaining us about you can say, a property of a material, right? What exactly it is? Now, let's suppose this is your spring, right? And this spring has, for example, the original length is L naught, right? You're applying a force. Force means a load, or you can say a weight, which is equal to, you can say the weight, and weight is basically W is equal to mg. That is the weight which is acting in the downward direction. Now, question is, as soon as the weight is applied, the spring will be stretched, or you can say expanded, right? And let's suppose the new length of a spring is L1, right? So question is, if you check this one out, right, you can say that the extension of the spring can be given by L1 minus L naught, which is equal to x. So my variable is x. Now question is, because weight is acting in the downward direction, right? So we are taking it as a force acting on the spring. Now, can I say that weight force which is acting in the downward direction, that load, right? I can say that if you increase the force or a weight, x value, which is also called extension, also increases, right? So it simple means that when you increase the weight force or when you increase the load on the spring, the extension or the spring will extend more and more and more. So I can say that F is directly proportional to X value. So force is directly proportional to X value, right? Once you remove this proportionality sign, here comes equal to sign and a constant K multiplies with it. So you will have a formula F is equal to K, where K is equal to force upon X, which is Newton per meter. And what is this K? We call this stiffness of a spring, right? This law, which I'm talking about, is called as Hooke's law. But there is a small twist. And what is it? Let's talk about this. If you keep increasing the load here, keep increasing it, what will happen? Now, there are 2, 3 things. If you put the load along with that spring, it will expand or extend, whatever. Once you remove it, what will happen? It will go back to its original shape, right? And if any object, after having a load attached to it, and once you remove that, it goes back or it went back to its original shape, we call that a elastic material, right? So this material shows the elastic material, or if you say the property, you can say it's called elasticity of a material. Because if you stretched any rubber band, for example, you stretch it to a level, and when you leave it, it comes back to its original shape. And we call this property as an elastic property or elasticity of an object. So what is elasticity? Elasticity is the property of an object that when force is applied, now I'm talking about generally, on an object, it stretches, and as soon as force is removed, the object comes back to its original shape. That is what we called as elastic behavior, or you can call it elasticity as well. So the question arises, how long this elastic behavior of this particular spring will last? You will keep increasing the force, and then once you remove the load, it goes back to its original shape, as we are talking about. But will it be forever? Like if you keep increasing the load, let's suppose you increase the load by 2 Newton and you remove it, the object goes back to this original shape. If you increase the load by 3 Newton, it will, and remove it, it will goes back to this original shape. What if you increase the load by, let's suppose, 100 Newton? Will, if you remove that, and will it go back to its original shape? That's what my point is. Actually, what happened? There is a limit now. It means there is always a limit to everything. So if you increase the weight to a certain limit, or if you increase the force more than a certain limit, even if you remove the force, it will never go back to this original shape, but the shape will be small, stretched. Like the rubber band original shape is being changed, or you can say distorted. And that means there is a limit to everything, and we call that limit as a elastic limit. So what is elastic limit? Again, what is the elastic limit thing? Elastic limit is the limit of a force, or you can say it's the limit of an object within which if the force is applied on an object and remove the object will come back to its original shape. So this is what the elastic limit is. If you go beyond the elastic limit, the limit of proportionality will no longer be whole. Now, what does that thing means? It means that that particular law, which I just said it, F is directly proportional to Kx. This will only last within the elastic limit. So basically, what is Hooke's law saying? That force applied is directly proportional to the extension within the elastic limit, or within the limit of proportionality. Once the limit of proportionality of an object bypassed, this law, which is F is equal to Kx, will not hold anymore. And it simply means that this law never holds for any particular force more than the elastic limit. Now, remember one more thing. Now, I'll show you the graph, right? And what does graph says about it? We can draw a graph between the extension and the force, right? If you see the graph, you can see that initially, if the force will rise, or if you can see the extension rises, force rises directly, right? That straight line shows that force and extension are directly proportional, that straight line, right? This is called linear region, or we can also call it elastic limit region, or we can call this point as a limit of proportionality point, this one. If you see this point, limit of proportionality, what does it mean? Once the force reaches to this point, which is the elastic limit, if you increase the force more than that point, you can see that F will no longer be directly proportional to X, but rather it shows you a curve. And that curve actually means that the force and extension will no longer be directly proportional. Their relationship will be gone. It will not be directly proportional. That limit, which is beyond that limit of proportionality or elastic limit, is called as plastic limit. In plastic limit, even if you remove the force as the original shape will not be regained, but rather it will be distorted. And if you keep increasing the force in the plastic limit, the shape of an object keep on distorting until if you keep increasing the force, the point will come which says the breaking point, and that particular object will be broken down. This is called breaking point. So, what is Hooke's law? Hooke's law means the force is directly proportional to the extension within the elastic limit, right? So, one more thing. We know that F is equal to Kxa. Now, very interesting. If you have a graph here in which on the y-axis you take it force and on the x-axis you take extension, so you can see that K value is equal to F upon X. To find the K value, you have to have a gradient of this linear thing. I mean, this linear side of the graph. So K value can be found out by finding the gradient of the linear graph. What will be the gradient of the linear graph? It will be F upon X for the, because F is Y and extension is X. What if the graph is like that, in which your x-axis will be force and your y-axis will be extension? Now we know that the value of K is F upon K. In that case, your gradient will be X upon F. So technically speaking, in that case, the K value will be, you actually found out gradient, and that gradient will give you 1 upon K value. So whatever value will come up, you have to inverse that value to get the K value, right? So this is what all about. This is what the graph is all about and everything. So technically speaking, if you've been given 2 points in them, you can simply find out the gradient, which is y2 minus y1 divided by x2 minus x1, right? That is, you find out the K value. And what is the unit for K? Newtons per meter, right? Now, let's solve one of the questions so that you will understand what kind of question is it. I mean, what kind of questions are coming for this Hooke's law? Now, here is a question. The question is very interesting. He said in a figure below shows the forces acting on a child who is balancing on a pogo stick. The child and a pogo stick are not moving. The spring constant for the spring pogo is, so spring constant K is given, which is 4900 Newton per meter. the weight of a child causing the spring to compress. Now remember that X can be compression, and can be expansion. Both things can be possible. And they're saying elastically, it means they're talking about the linear one. From a length of 40 centimeter to a new length of 33 centimeter. So L naught is given as 40 centimeters and the new length is given as 33 centimeter. So what is the X value? 40 minus 33, which is equal to 7 centimeter. You better change it into divided by 100, so it will be 0.07 meters. The question must be, what is the force applied, or what is the weight of a person? We know that F is equal to kx, and you can simply say that K is 4900 and multiply by 0.07. And that will actually tells you what will be the value of the force. Now, let me quickly solve that and let you know. It will be 4900 multiplied by 0.07. So it gives you 343 newtons. That is the weight of a child that is actually jumping at. That is how you actually found out the weight of a person. Now, there is a small topic associated with that, and that is what we call as circular motion. That is called a miscellaneous topic. This is not related to that, but actually this is your A2 topic, but let's talk about that, not very much briefly, but some very basic things. When the object is revolving in a circle, there are two velocities an object has. One velocity is called as angular velocity or speed, whatever, due to the chain in the angle. And forget about that. We are not talking about this because this is not a part of our syllabus. But one velocity is a simple velocity. Now, this is very interesting. At each point, you can see yourself, the direction of velocity changes because velocity has a direction, and the velocity direction will be tangent to the circle. You can see yourself, tangent to the circle. So the question arises, during the circular motion, even if a body is moving with the constant angular speed, it means that magnitude-wise of linear velocity or magnitude of the velocity will be constant as well. We are considering a constant circular motion, remember that. So it means linear velocity will be constant. Magnitude of the linear velocity will be constant. But the problem is started. My question is, if even the body is moving with a linear velocity, constant linear velocity, will there be any acceleration produced? Because magnitude is constant. Yes, there will be an acceleration because there is a change in the direction of the velocity. And that velocity is, that acceleration is acting towards the center. So acceleration will be produced, and that acceleration is called as centripetal acceleration. And that acceleration is always directed towards the center. And due to this acceleration, a force is also produced, which is acted towards the center. And we call that as a centripetal force, right? Centripetal force. Now, this force, what are the things which are important for that? There are a few things which are very, very important. Acceleration or a force, centripetal force, is directly proportional, or you can say you need a will be, or you can simply say that acceleration can only be increased if velocity will be increased. So it is increased by the factor v square, like v square and a. AC are directly proportional, right? Or you can simply say if the velocity increases, acceleration or centripetal acceleration increases. Same thing happened for the force as well. What if the radius of this circle increases? The radius of the circle has inverse relationship with the centripetal acceleration as well as with the force. So technically speaking, it's inversely proportional. If radius increases, centripetal acceleration reduces and the force reduces as well. With the mass, the force has a direct relationship because F is equal to ma. So centripetal acceleration increases if mass increases, centripetal force. So acceleration is directly proportional to the velocity and inversely proportional to the radius of a circle, while force is definitely directly proportional to the velocity, inversely proportional to the radius of a circle, and also directly proportional to the mass, right? This is what the centripetal motion or circular centripetal force or centripetal acceleration is. Now, there are a few things which actually, one more thing which is very, very important, and that is basically, we called it friction. Now, what exactly is friction force? Friction force. Now, remember that when you say friction force is everything to do with resistance. For example, this is the surface and you have an object which is sliding. If you slide this object, for example, there will be a force produced between the surfaces and that tries to stop the motion. Stop the motion or resist the motion. Resist the motion, right? Resist the motion, and that thing is called as friction force, right? In solids, we do call it a friction force because that tries to stop the motion of an object, right? It is due to the imperfection of the surfaces. If the surfaces are imperfect, due to that, this is produced. Because their surfaces are not plane, not straight, then due to that, friction will be produced, which is always in the opposite direction of the motion. If you're moving in the right-hand side, the resistance will be on the left-hand side, right? So this is happening in the solid. The same thing happened in the liquid as well, right? In liquid, if the body is going downward due to the weight force or whatever, there is a resistance force that resists this motion in the downward direction that acts in the upward direction, and we do call it viscous drag. In the books, we don't see this viscous drag. We do just see the drag force because there must be a net force acting on an object because body is going downward. So viscous force is acting in the upward direction, right? This is for the liquids, right? So in solids, it's due to the imperfection of the surface. In liquids, it's due to the thickness of a liquid, how thick the liquid is, right? If more thickness is there, there will be more viscous drag in the upward direction. So there is a net force which you're talking about will be the weight force minus the viscous drag or whatever, right? So in a solid, we do have due to imperfection, and in the liquid, we do have this due to the uh, thickness of the liquid. So these are three topics we have covered in this lecture number 7. One lesson is, one topic is Hooke's law and related problems and everything. We did cover circular motion and friction, right? In the next lesson, which will be lesson number 8, we will be coming up and we'll try to finish moment and its related problem. I hope you like it. Hope to see you in the next lesson. So it's bye from my side. Thank you very much.